Hey friends, here we go with day 2 of our bell ringer, and we're going to start with our daily fact family. Now remember, for those of you who have been with me for a little while, I use this as a way to refresh your memory about vocabulary. So what do we call the answer to a multiplication problem? We call it our product. And the two numbers that we multiply, those are our factors. So for this first part, we have a factor times a factor equals our product, okay? Now, we can reverse those and still get the same product. Do you guys remember what property tells us that we can reverse our factors and still get the same product? I'll give you a hint. What do your parents always complain about in the afternoons when they're tired coming home from work? Vroom, vroom. That's right. They complain about their commutes. The commutative property is the one that tells us that you can multiply 7 times 11 or 11 times 7 and still get the same answer or the same product. Okay, for division, we take our dividend, we divide it into groups, and the number that we divide it by is called our divisor, and then our answer is called our quotient. So in this case, our dividend is going to be the same for both equations. Dividend, it's going to be 77 for both, divided by the divisor. I'm going to run out of room here. Divisor. Oops. Okay, so our dividend divided by our divisor gives us our quotient or our answer. So 77 divided by 7 equals 11, or 77 divided by 11 gives us our quotient, which is 7. Okay, next we have our measurement problem. Do you guys remember that silly little rhyme I taught you to help you remember? If you are converting a unit of measurement from a larger unit, like pounds, to a smaller unit, like ounces, you're going to think horse to fly, multiply. Because, of course, a horse is bigger than a fly. So you're going to have more of that smaller unit of measurement making up your larger unit, okay? So 48 times 16 ounces in a pound will give us our total number of ounces in 48 pounds. Okay, so now this is where you guys are going to be happy we've been practicing our multiplication. We're going to multiply 48 times 16. There's lots of ways to solve this problem. You guys pause the video, solve it, and see what you get. And then when you come back to me, I'll show you the way I would solve it. I would just use the US algorithm, but I also am a huge fan of the array method, so it's really up to you. Let me go ahead and start. I'm going to start by multiplying my ones place. 6 times 8 gives me 48. Put down your 8 and carry your 4. 6 times 4 is 24. Plus 4 more gives me 28. Now I need to put a 0 here as my placeholder because I'm done multiplying my ones. And I also am going to cross out this 4 because I've already added that, and I don't want to get confused and add it twice. All right, so now let me start by multiplying my tens. 1 times 8 is 8. 1 times 4 is 4. Now I'm going to add my two partial products. 8 plus 0 is 8. 8 plus 8 is 16. Carry the 1. 1 plus 2 plus 4 gives me 7. So that's 768 ounces. All right, now I'm going to take 64 ounces and I'm going to divide that by 16 ounces in a pound. And I'm going to divide because fly to horse, divide, of course. A smaller unit of measurement converting to a larger one, we're going to divide. If you're having a hard time visualizing ounces versus pounds, think of pounds as being like big, heavy things that people lift weight with in the gym, right? They're like those big barbell looking things. Whereas an ounce, when I think of ounces, I think of like ounces of butter to make cookies or ounces of flour. So it's a smaller unit of measurement, not something so big and heavy. One good thing that is helpful to do, parents, if you're listening in on this video, start pointing out to your kids places where you see things being measured in ounces versus pounds, just to help them kind of get used to the context in which you might be more likely to use pounds or situations where you might be more likely to use ounces. Okay, so we're going to divide 64 by 16. Now, again, I want you to pause this video and think about how you would do that. Now, I know some people, their go-to division strategy is to make their little house symbol. Your dividend is going to go inside the house, so 64 will go inside the house, and your divisor goes outside the house. So 16 will go outside the house, and then you go through the process of dividing that way. So I'm going to show you a method of dividing called partial quotients, and I'm not sure if your 4th grade teacher has taught you this or had taught you this before you guys got out in the spring, but tell me what you think about this method, because I like it because it allows me to kind of experiment with the numbers and think about how many times 16 can go into 64. So I'm going to start by saying, okay, 16 times what will get me close to 64? Well, I know that 16 times 2 is 32, so I'm going to start with that. I'm going to take this product here and subtract it from my total. So 64 minus 32, 4 minus 2 is 2, 6 minus 3 is 3. Okay, now I have 32 left to kind of share out. So I'm going to say another 16 times 2 will give me 32. I'm going to take this product and take it away. Now I have a remainder of 0. So I know I'm done dividing. And how many groups of 16 did I actually work with? I've got 2 here and another 2 here. So that means that 64 divided by 16 is exactly 4. So I'm curious to know if you have done division this way. It's called the partial quotients strategy. Okay, here we go with our volume problem. And you probably remember from before fall break that we had talked about volume is the amount of space that a 3-dimensional figure takes up. So another way to think about it would be like if this were a box, a cardboard box, how many of these little cubes could we fit inside the box? And the volume is the measure of how many cubes we could fit inside the box. So what you want to do is start kind of training your brain to look at these figures as layers of cubes. So here I've highlighted in blue the bottom layer of this figure, and it looks like it's, let's see, 1, 2, 3, 4, 5, 6, 7 cubes across, and then it has a depth of 2 cubes. So that means that this bottom layer is made up of 14 cubes. Even though you can't see 14 cubes, I know that behind this square is another cube, so that's a group of 2. Behind this square is another cube, that's another group of 2. Behind this square, that's another group of 2, and so on. So if I were actually building this figure with cubes, I would have a group of 7 cubes. 1, 2, 3, 4, 5, 6, 7. And then behind it, I'd have another 7 cubes. That doesn't look quite right. How do I draw this? Okay, there we go. So this is kind of what it would look like if we lifted off all of those layers and you were just able to see just the bottom layer. So that's a total of 14. Then we're going to look at how many layers we have stacked up on top of each other. So we started with 1 on the bottom, then we go 2, 3, 4, 5, and 6. It has a height of 6 cubes. So that's like saying, let's take this bottom layer of 14 cubes and stack up 6 of them on one on top of the other on top of the other. So let's see, here's 1, I'm trying to kind of arrange it. 1, 2, 3, 4. I'm going to run out of space, of course. Can I make it smaller? There we go. 1, 2, 3, 4. 5 and 6. Okay, so what I've done here, hopefully you're still with me, is I've taken this figure and I've kind of deconstructed it into 6 layers of 14. And the reason I showed you that was because I want you to understand why we're multiplying length times width times height. We're going to take our 14 and multiply it times 6 because that's our height. 1, 2, 3, 4, 5, and 6. I don't count these as separate cubes because they are a part of this cube here. 14 times 6, let's do that. 6 times 4 is 24. I'm going to put down my 4 and carry my 2. 6 times 1 is 6. Plus 2 more gives me 84. So we've got 84 cubic units. That's our volume. All right, here we are in our geometry problem. We're going to name and tell everything we can about the shape. And of course, we know that the 5th grade or even 6th grade way of saying name and tell is identify and describe. So before fall break, we had talked a little bit about 3 types of angles: right angles, acute angles, and obtuse angles. And I want to go back to that and kind of refresh your memory. I don't know how hard it is for you guys to remember things from before fall break, but let's review. A right angle is exactly 90 degrees. And the way you indicate a right angle is by making a little box here to show that it's exactly 90 degrees. And the way that you test whether or not something is a right angle in the classroom, what I would have you do is take a little piece of paper and rip off the corner of it and then just put that corner in the shape that you're trying to measure. And then you can see if the corner fits in the corner of the shape with no extra, then it's a 90-degree angle. So here we can see that this angle is 90 degrees because it's fitting right in that corner. So this is a right triangle. It has one 90-degree angle. And then we can take this same shape, our little square here, and kind of slot it into the corner of the triangle up above and see that, of course, that is an acute angle, this angle here. This is an acute angle because when I make another square and try to fit it in there, of course, you can see that this angle of my square is way bigger than the angle of my triangle that I'm testing. So this is an acute angle, and this other one here, that's also an acute angle. So we have 2 acute angles and no obtuse angles. So we can cross out obtuse. Now here's a fun fact about triangles. I'm curious to know if you guys learned this last year. I'm sure you did. Did you know that if you add up the angles of a triangle, so angle A, angle B, and angle C, when you add them up, you get a total of 180 degrees always, 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 always. So we know that this angle is 90 degrees. And we don't know these two, but we do know that combined together, it's a total of 180 degrees. Okay, one more to go. It's our line plot problem. So I'm going to draw my x-axis. Remember that your x-axis is a horizontal line that goes side to side. And a line plot is just a way to organize data so that you can see patterns. Now these line plots are kind of different because we don't know what these numbers represent, which defeats the purpose of organizing them, but whatever. We'll practice anyway. It looks like our smallest value is 30, and we need to find our largest value because that's where we will end our line plot, and I'm thinking 70. Yeah, okay, so we'll go from 30 to 70. Let me see if I can do this without having to redo it a bunch of times. 50, 60, okay. All right, and then I just start plotting my points. Each number on my line plot is going to be represented with an X. Each piece of data on my line plot is going to be represented with an X. So 1X for 30, 1X for 35, 1X for 40, 1X for 45, 1 for 35, another for 35, 1 for 55, 1 for 60, 1 for 70, and 1 for 40. Okay, now do you remember this word? Mode, not pie a la mode. I'm not talking about ice cream. I'm talking about your most frequently occurring piece of data, which in this case is 35. So 35 is my mode. That's the piece of data that's occurring the most frequently. And our range is between 30 and 70, because that's our smallest value to our highest value. Okay. That's it, guys. That wasn't too painful, was it? Now remember, I'm going to post one of these each day, so by the end of the week, you'll be done with all of your bell ringers. So just make sure that you're going back to the Monday folder each day and adding your work for the bell ringer for that day, and then at the end of the week, go ahead and submit it. Okay, I hope you guys are having an awesome day, and let me know if I can help you with anything.